Good morning. This is Miss Billerbeck, and we are going to talk about systems of linear inequalities. So as soon as we talk about more than one inequality, we have created a system. So you can see we have two inequalities, one in the red and one in the blue. And where they intersect with the shaded area, that is the solution to those inequalities. And the solid line is also part of the solution, though this dashed line is not. So let's take a look at an easy example of this, how we would find this on our own. So if we take a look at this one, we have y is less than 2x. Well, we see that we have a 0 for a y-intercept. So we're going to plot the point here. And then we're going to rise 1, 2, run 1. So rise 1, 2, run 1. Okay, we also look at this. There's no equal bar under there, so we're going to make it a dashed line. Let's see, got a little off there again. Let's see, there we go. All right, so we have a dashed line here. And that's just giving us a boundary. So now we have to decide, well, where does it go? So it could be on this side or this side. The less than sign makes me think it's below. I can take a test point right here and plug in 3, 0. So that's 3, 0. So it's 0 less than 3. 0 is less than 3, so we are going to shade this area. Okay. So now let's take a look at the other equation. So we have y is greater than negative 3. So you should use a different color. So this is where colored pencils are wonderful because you can erase them. Okay, so we go to y is negative 3 right here. It's no equal sign, so we're going to make another dashed line. And it looks like the intersection will be over here, so we'll put most of the line over here. Okay, probably should carry it a little bit this way. Okay, put our little arrows on this. Now we have to figure out which side do we shade. So it says y is greater than negative 3. So that means that we could use test point 0, 0. 0 is greater than negative 3, so 0, 0 is true. So we're going to shade this direction. It's much nicer when 0, 0 is not right on the line, like it is right here for this line. But there's always other points we can use. Okay, so we see some overlapping going on here. So that we can use either a darker pencil or a different color and just start shading in that intersection. So that is the solution right there. So you shade that in. And so you know that that's the solution. So it takes just a little time. Okay. All right, let's try this with something that is a little bit more difficult. All right, so if we have y is greater than or equal to negative 2x plus 1, we're going to start with the plus 1. And then we're going to rise negative 1, rise negative 2, run 1. 1, 2, run 1. So make sure when you draw that as x increases, y is decreasing, so we have a negative slope. We have an equal bar right here, so we're going to make a solid line. Okay, and then we make our arrows like this. Okay, so 0, 0 is not on the line this time, so we can put 0, 0 in there. 0 is 0 greater than, this term cancels out, so 0 greater than 1. No, it is not, so that's not part of the solution. It's also greater than, which means it's above the line. All right, so let's graph this line now. We'll use a different color. Let's use 2. So we'll start with 2 for, and then we rise 1, run 1. Rise 1, run 1. Okay, so that is going to look like this. All right, so now the next question we ask, oh, is it dashed or solid? It is a dashed line, so we have to go and erase a few of these right here. Good thing it's easy to erase when we check that one little thing. So now is it going to be above or below the line? This is saying that it's going to be above, which means 0, 0 should not be part of the solution. So 0 is 0 greater than, this is 0 plus 2, so is 0 greater than 2? No. So we shade the other side of the line. Okay, so now we can see where they're crisscrossing, which is their solution. So we can shade this in with either a darker pencil or, completely solid with pencil. But we just want to make sure that our solution is well represented. Okay. Since these are both greater than, it kind of makes sense that our solution is going to be above. All right, so sometimes we have to figure out what the equation is from the graph. So let's take a look at the blue line. So it has a y-intercept of -4. So we have -4. That's a 4, not a y. There we go. Looks much better. Then we need to find where does it cross the little grid line. So it looks like it's crossing here. So 1, 2, 3, 1. If that's true, we can go up again. 1, 2, 3, 1. 1, 2, 3, 1. So it looks like I have a rise and run of 3/1, which is just 3x, and then I have y here. So I have to figure out the inequality sign. There's obviously an equal bar because this is a solid line, but is it greater than or less than? Well, because it's below, I'm going to favor on the less than sign, which means 0, 0 is not part of the solution. So if I put 0 is less than, this cancels. So 0 is less than -4. It is not. So we have the right equation for this one. Now let's take a look at this graph. So it again has a y-intercept of -4. Okay, we have a negative slope as x increases, y is decreasing. So we see it hits here. Looks like it's rising 1, running 2, rising 1, running -2, rising 1, running -2, rising 1, running -2. So that looks like it's got a slope of -1/2 from that. So we have y here. It does not have an equal bar, and it's below, so I'm going to favor on the less than sign. Now let's try 0, 0. Again, it should not be true because we shaded the other side. So 0 is less than -4. That is not true. So we picked the correct inequality sign for both of these, actually. Okay. So let's take a look at this one. So if we start with the blue one, we see we have a y-intercept right here at 1. So we have a y-intercept at +1, and we run 1, 2, 3, 1, 1, 2, 3, 1. So that looks like it's a 3/1, which is just 3x. And we have a y. It's dashed, so there's no equal bar here. So it looks like everything's below, so that would mean a less than sign. And it does include 0, 0, so this should be true. So if we put in 0 is less than, this cancels, so 0 is less than 1. That is true. So we picked the right inequality sign. All right, now let's try this one here. So we have a solid line, it's horizontal, so that's an x, and we have an equal bar since that is a solid line. It's at 1, and it's going to the left, so that makes me think it's a less than sign. It does include 0 in the shaded region, so 0 should be less than or equal to 1, which is true. So that's how we get our two equations. All right, so let's do a real life problem. Okay, when you're running a business space is very expensive. Okay, safety is also very important. So we have Alexa who wants to set up a wellness clinic one day, and was wondering, she has $600 for a budget for disposable gloves, which cost $18 per 100, and disposable masks, which cost $14 per 100. And she was wondering, can she purchase 25 boxes of 100 gloves and 15 boxes of 100 masks if she can only store 40 boxes? So we have two inequalities. Okay, so the first one's about budget. So she has to make sure she has the budget to buy the correct amount of gloves and masks and stay within $600. So if we call X will be gloves, okay, and Y is going to be the masks. Okay, we can't use, with Desmos, we can't use other letters for inequalities. We can only use X and Y. So that is why I'm not being creative and using G and M. All right, so we have $18 per 100 pairs of gloves, so 18X plus $14 per 100 masks. And so that will be Y. And we have a budget. So whenever we see the word budget, that means we can't go over budget because no one's, especially if we're running a business, we may not have the money. So that's a bad thing. So we want to be less than or equal to our budget, which is $600. Okay, so that's our budget. Now we have this space issue. Okay, so we have X amount of boxes that we bought and Y amount of boxes we bought, but we only have space for 40 boxes. So that means that we have to buy less than or equal to 40 boxes. Okay, so we have our two inequalities. Now we're set to put this into Desmos and make a business decision. So let's go to Desmos. All right, so if we go to this, we have, first let's put the budget in there, 18x, and then plus 14y, and we're less than or equal to 600. Okay, so that's our budget equation. Now let's take a look at our space equation. Like that so we can see it a little bit better. So our space is x plus y, and again, that one is less than as well. So less than or equal to, but we can only put 40 boxes into the storage area that we have at our business location. Okay, so we see we have an overlapping region right in here of combinations of things that would allow us to be successful. We could buy just 20 boxes of, the Y is the mass, so 20 boxes of mass and 10 boxes of gloves. But we probably need a few more gloves, so we could buy 20 boxes of gloves, and we could even make it to 15 boxes of mass. But let's look at 25. So if this is 30, that's 25. So it says, can we buy 25 boxes of gloves, which is our X, and 15 boxes of mass? So we go up here carefully. 1, 2, 3. Uh-oh. We're out of budget. Wait, that's the space one. We made the space, but we're out of budget. Okay, we just barely missed the budget. So we cannot buy 25 boxes of gloves and 15 boxes of mass. So we're going to have to go reevaluate and go to, if we say 25 boxes of gloves, we can afford 10 masks. Okay, so do you see how important this could be for your business? So if you're able to make inequalities running a business, it's just remarkably important. All right, so that's it for the real life problem. I hope that was something that you could relate to. So anyway, I hope you learned a lot and have a wonderful day. Bye-bye.